Today's lesson is on slope and y-intercept. So what do you think about when you hear the word slope? I think about ski slopes, going skiing, and it's related because I want you to think about skiing down a hill. There are different types. You could go down a black diamond, which is going to have a very steep slope, or maybe you go down the green easy one that has more of a gradual slope. That's the same idea. This whole unit is on the linear function, which we already know, functions that create straight lines. And the first lesson is about the slope of lines, the steepness of these lines. So first, some introductions to this unit. We have this equation at the top, y equals mx plus b. We're not going to talk too much about that equation, other than that's the general form of the linear function that we'll be using a lot this unit. And the reason that I wrote it is because when we refer to slope, we give it the variable m, and then when we refer to y-intercept, we give it the variable b, and that will always correlate back to this equation, y equals mx plus b. Throughout this unit, we will be finding slope in a lot of different situations. So here I have 3 different things that we will refer to often. To find this slope, you have to find rise over run, which I will explain that, vertical change over horizontal change, and then we've seen this last part, change in y values divided by the change in x values. Those 3 things are really saying the same thing. If I just draw a line here on my graph, the slope, if you find 2 points on your graph, we want to look at the vertical change divided by the horizontal change, which is the same as the change in your y values divided by the change in your x values, which we often say is just rise over run. How much do you rise? How much do you run? And I will talk more in detail about that later. And now the y-intercept is the point on a line that crosses the y-axis. So if you remember, we have the x and the y-axis. On your diagonal line, wherever it crosses the y-axis, that is your y-intercept. And the y-intercept, just a reminder, is when the x value is always 0. Now we're going to draw some general lines that represent different kinds of slope. And when you're thinking about slope, I always want you to think you're moving left to right. So a positive steep slope is our first graph. Positive, you have to start left to right. Positive, it would be as if you were going uphill. And this would be an example of a positive steep hill. That would be a difficult hill to climb. So left to right, here's my little stick figure, is climbing up the hill. Therefore, it is positive. So then a negative gradual slope, from left to right, instead of going uphill, we want to be going downhill, and then a gradual slope, something like this. So from left to right, my little stick figure is walking downhill. Okay, the slope is 0. This would be an example of you're not increasing or decreasing, so you're just walking a flat line. There is no slope. No increase and no decrease. Slope is 0. And then the last one, slope being undefined. This is a vertical line. The slope is undefined. And to help me remember, I just always think about walking the line. Are you walking uphill? Are you walking downhill? Are you walking on a flat surface? Or if you try to walk a vertical line, you are falling off a cliff and you die. Therefore, the slope is undefined. So, just a little fun way to remember. Okay, now we're going to actually find the slope of different lines. And we're going to use the idea of rise over run. So rise over run, we want to see how the line between 2 points, how it rises, so how it changes vertically, and then run is how it changes horizontally. So 2 points are chosen for you in this example, and I'm going to connect them with a vertical line and a horizontal line. And as you can see, remember left to right, if you walk this line, you are going downhill. Therefore, your slope has to be negative because we have a negative slope, you're going downhill. So to find the rise over run, the rise, always start with the left point, and we want to move to the right point. So left point to the right point. Rise, which means how many units do you have to go up or how many units do you have to go down? And in this case, we have to go down 1, 2, 3, 4. And since we're going down, we want to think of that as -4. My rise is -4 units. And then my run, how many units do I have to go to the right? 1, 2, 3. -4 thirds. And you always look to divide, if you can, to get an integer, but if you can't, you're just going to leave it as the fraction, -4 thirds. So my slope is -4 thirds, and then my y-intercept, where does the line cross the y-axis? So here's my y-axis, here's where my graph crosses. It crosses at the point 0, 2. So the point 0, 2 is my y-intercept, which we also can just write as b equals 2. So there is my slope and my y-intercept of that line. Okay, same thing in this next example, finding the slope. So if you look at the 2 points that they gave you, start at the left point, and we want to move to the right point, but we want to move vertically and horizontally. And as you can see from left to right, it's going uphill, so our slope is positive. So from the left point, we have to go up and over to the right. So how many units do we have to go up? M equals, we go up 1, 2, 3, and over 2. So the slope is 3 over 2. And then the y-intercept is at -1. So you can say that b equals -1, or you can write it as the point 0, -1. Alright, in this one, we have a line, and it is increasing from left to right, so it's once again going to be positive. But in this case, they didn't give you points. You have to find your own points. So let's quickly just look over at this example. Where do you find points? You want to find at the corners. Where does your line cross at the corners? So if you see here, this is a good point because it crosses right at the corners of your grids, where this is not a good point because it doesn't exactly fall right at a corner. So you can pick any 2 points. Let's see, I have one here, and I have one up here. So let's find the rise over the run. The slope, I'm going to rise 1, 2, 3, 4, 5, 6. My rise is 6, and then my run is 1, 2, 3. And 6 divided by 3 is 2, so my slope is 2. But before I move on, let's look if I were to have chosen 2 different points. Let's say this point, and I put a point here. I would go up 1, 2, 3, 4 over 2. My rise is 4, my run is 2, and 4 divided by 2 is 2. And then last example, I even could have put points here and here. Up 2 over 1. 2 divided by 1 is 2. So no matter which points that you choose, after you divide, the slope is the same, which makes sense because it's a linear function and has a constant slope throughout the whole line. And then real quick before we move on, the y-intercept, it crosses at -4. So b equals -4. Okay, the last three examples, you were just given 2 points. We're going to plot the points, make the line that connects them, and then find the slope of that line. So first, we have the point -2, 3, and then over 4, up 0. And if we connect this, we're going to find the slope of that line. And it is from left to right, it's going downhill, so my slope is going to be negative. Always start at the left point, and we're going to have to move down 1, 2, 3, so -3 over 1, 2, 3, 4, 5, 6. So the rise is -3 over 6. Always reduce your slope, which is -1/2. So m equals -1/2. Okay, let's plot these 2 points, -3, -2, and then over 1, down 2. If we connect them, you can see that the slope is neither increasing or decreasing, which means the slope is 0. And here is our last example. Let's plot the point 4 over 4 up 4, and then over 4 down 1. If we connect these, it makes a vertical line. And just remember, if you try to walk that line, it's as if you're falling off a cliff, and if you fall off a cliff, you're going to die. Therefore, the slope is undefined. So there's the full lesson on finding the slope of linear functions and finding the y-intercept. Good luck with the lesson.